there it is. Okay, so this is the third period live stream for Wednesday, February 5th, 2020. The warm-up, solve y equals x plus 5 times x minus 3. This is already, ladies and gentlemen, in factored form. So all you have to do is set those two factors equal to 0 and solve for x. So x plus 5 equals 0. Subtract 5 on both sides. And we get x equals negative 5. And then you have x plus 3, or sorry, x minus 3 equals 0. And you add 3 on both sides. And you get y equals, or sorry, x equals 3. So we believe that these are the solutions. But we can't rest comfortable, can we? We have to check. I'm going to show you how to check on the calculator. So the factored form of the equation is x plus 5 times x minus 3. Let me go to the calculator, 2nd plus 7, 1, 2, and I'm going to clear the key history. Let me go to y equals. Open parentheses, x plus 5, right? Close parentheses, x minus 3. Was that how it looked? Now, hit graph. And just look and see where it crosses the x-axis. Count. Negative 5 and 3. So does that match what we think it was said? What's the y-intercept of this factored form equation? Just do the L part of FOIL. Who said it? Gracie. Good job. Guess what? You're going to get a chance to go into this special candy bucket right here. This was what they gave me for getting Teacher of the Month for Elliott Auto Group. Come and look in here and open one of these up that you like. Let's just dump the whole thing in. It's all kinds of good stuff. Really good stuff. So... Oh, you probably don't want that math homework. Yes, sir. Say what? Okay, so, yes, sorry. We multiply last, you're welcome, last times last, and we got negative 15. So remember, in the standard form equation, ax squared plus bx plus c equals 0. C is the y-intercept. So if you know how this thing works on FOIL, you know that when you do L times L, last times last, or 5 times negative 3, you're going to come up with a whole number, or the constant part of the equation. And you know that the constant part of a quadratic is the y-intercept. So Gracie just did all that in her head real quick, and so that was impressive. Negative 15. Let's make sure that she's right. Let's go back to our deal here and hit second graph. And let's go down and find out where x is 0. What is y? Bingo. See that? So good job. All right. Let me just skip all these. I want to teach you how to factor and solve quadratic equations where the leading coefficient is something other than 1. So all of the ones that you did last night, it was like x squared plus 2x plus 5, or x squared minus 7x plus 3, or something like that, where a was always 1 last night. That was what we said, okay, a equals 1, therefore we can do our simple factoring. Well, now, here's the problem. Those represent about 1% of the total quadratics. That's the kiddie pool, right? The little shallow end. And that's where you start. Okay? But now we're going to move into the middle part of the pool. All right? We'll save the high dive, deep end of the pool for later. But this is the middle part. This is where 90% of your quadratics are going to live. So we got to learn how to deal with them. Best thing in the world. The best way to kill your ability to do something is to make you read and write a bunch of nonsense from the book. Okay? Let me just show you how to do it. Let's take 7x squared plus 29x plus 4. Let me just go over here. So this was our example. And what page did this come from? 510? What are you doing, bro? This is the example from page. Okay, I see what's going to happen. We go and play. The example from page. What page? Somebody wrote it down. I know they did. 510. Thanks. Seven x squared plus 29x plus 4. So let's do this. Let's solve it. Solve y equals 7x squared plus 29x plus 4. I want to kindly acknowledge that two of my favorite students are currently talking and that I would like that to stop. Okay, so let's get back to basics, ladies and gentlemen. You guys see how that was like a double-sided thing? It was a compliment, but then there was a critique. Would the absolute genius who is currently talking please stop talking? It's like, well, wait a minute. Am I supposed to be mad because he called me a genius? But I'm talking. What is A, Joseph? Somebody said it to him. Don't do that. Make him do the work. Joseph, and only Joseph, without any help from the other members of our esteemed audience. How are you doing today? Good. Matthew, what is B? 29. Very good, sir. And Eduardo, what is C? 4. Correct. Now we're going to do a little analysis, see what we can get done using what we already know. A is greater than 0, so we know that the shape of the curve will be upward sloping. C, well, hold off there. So right now, ladies and gentlemen, that's all we know. Because now we need to learn something new. We are going to learn how to find the master product. The master product is equal to A times C. Eduardo, what was A?
7.
Okay. And Nathan, what's C? Samantha, what is 7 times 4?
28.
So the master product for this quadratic is 28. Not too bad, right? It's just one step more than you did before. You treat that master product like you treated C. So here's how we're going to do our analysis. The master product is positive, so both signs will be the same. So both signs of our factors will be the same. Now what's B? 29. So B is positive. Okay, so both factors, because B is positive and the master product is positive, which we used to say C was positive, since they're both positive, both factors are positive. I believe we're now ready to play our little game. Okay. Now this game's a little bit different. We are trying to find two numbers that add to equal B, and those same two numbers need to multiply to equal the master product. So let's substitute in our real numbers there. What was B again? You have to say it in Spanish. What was B again? 29. And what was the master product again in Spanish? 28. Okay. So we're trying to find two numbers that add to be 29 and multiply to be 28. What are they? Come on. It's easy. It's easy. It's easy. Don't overthink it. Thank you. Thank you to, I think Nathan and Gracie were kind of both about to say it, but Nathan, you got the words out first. So, sir, if you would like to come over here, and there is just a feast of really, really expensive chocolate, if this is your thing. I also will make available to you the normal bucket of candy in case you don't like chocolate or you're allergic to it or whatnot, and like such as, and therefore. What did he say? I already forgot. Okay, so what we're saying is 1 plus 28 equals 29. What happened? What happened to the door? Oh, okay. And 1 times 28 is 28. Okay? Now here's what you're going to do. This is the new part. You're going to take this middle term. Go away. You're going to take this middle term right here, and you're going to split it up. Now, you're going to associate the bigger number with, you're going to put the bigger number first. What'd I just say? Bigger number first. So what number goes right here? The 28. I want you to write 28x. Now, what should I put over this on the right side? X. 1x. Okay? 1x. Now watch this. This is cool. Y'all will like this. We're going to write, new line, y equals, this homeboy comes down right here, 7x squared plus 28x plus 1x, and then this homeboy comes down right here, plus 4. Did we change the problem? See, if we were to add back those middle coefficients, we'd be back to 29, wouldn't we? So we didn't change the problem. We just split that middle coefficient up using that master product thing. Is there any confusion about what we just did other than it's new and that's normal level of confusion? Anyone just totally lost on how we got where we are? Okay, bueno. Now, I want you to put parentheses around both of these things. Okay? In the words of Scarface, okay, man. Yeah. And now we're going to play another little game. All right? And that game is greatest common factor. We're going to greatest common factor both of these little expressions. Thank you. Wait a minute. Okay. Ooh, close. Yeah, okay, so let's look at the first one. Here, let me put these lines. What can you divide out of both of those? Nathan said 4, which was correct. Oh, no, sorry. Nathan said 4, which doesn't work because you can't pull a 4 out of the 7, right? 7. So the other factor of 28, right, is 7. So I could pull a 7 out. What else could I pull out of both of those? Who said that? No, it was over here. Okay, me said it. Me said put X. See, we can pull an X out of both of those as well. Now, over here, I want you to tell me that this one right here, okay, that's fully simplified. Okay? Just say it in your head. That's fully simple. There's nothing you can pull out of it, right? There's no common factor that you could pull out of it. Now, let's do a new line. Ladies and gentlemen, just keep with it. We're taking it slow and easy so no one gets lost. You okay, Sheridan? Sheridan, do you remember the parachute? You can do it for this one too. So, keep that in the back of your mind. The parachute, guys, is that you can stick this in y equals and be done with it in about 10 seconds. So just remember that that's available to you when it's like the STAR test. But right now we need to meditate on this. Okay? There it is. The meditate. We need to meditate. So remember what happens when we divide out greatest common factor. We're going to write it out to the left of the parentheses like this. Now do open parentheses and let's perform the division. What's 7x squared divided by 7x? 1x? Or could I just write x? Is that okay? Well, no, because x squared divided by x is x. So I'm just going to write x. And then what's 28x divided by 7x? Can you tell me the sign that goes with that number? Plus 4, right? So should I write x plus 4? No, because the x's cancel out. Okay. Eerie. I heard that. I know what it means now. You got to come up with another little code. Okay. So, when you cannot factor anything, remember we said that thing was fully factored, 1x plus 4? When you can't factor anything, you can factor out a 1. Okay? And that's kind of like, bruh.
Pardon the interruption. I would just like to let all of you know that the back doors are open due to rain. Thank you.
Okay, so here, this is something we'll just have to go over until you remember. That when you can factor out nothing at all, ladies and gentlemen, you need to factor out a 1. Okay, so I'm going to put that in red. Rojo. And it didn't change anything about what was inside. Are we all okay with what we have here? Yes. Now, this is the fun part. Brother, your definition of fun and my definition of fun are in somewhat of opposition, sir. But I'm glad you find your job interesting. Because if you didn't, it would be pretty boring to teach it all day. These two homeboys come and hang out together now. So now y equals 7x plus 1. And now put those in parentheses. Open parentheses. And now what you're going to do is, you see these two are exactly the same? Yeah. You see how they're exactly the same? That means that our other factor is x plus 4. Bueno. Okay, so now we're ready to solve this quadratic. You have fully factored this, by the way. If you were to use FOIL, you could turn it right back into the thing it started with. But let's go ahead and solve it first, then we'll check it later. So how do I solve quadratics once I got them factored? Set them equal to 0. And then solve for the variable. So let me ask Tamia to help me solve 7x plus 1 equals 0. What would be my first step? Ooh, yes, you will do that. But what is the thing you have to do before you do that? Yes. Minus 1 on both sides. And then we'll come back to do Tamia's step because that's a good step. So now I have 7x equals negative 1. Now, Tamia said divide by 7, and she is exactly right. Divide both sides by 7. Thank you, smart people. And so my x is negative 1/7. Uh-oh, we have a fractional x-intercept. In your head, I want you to be thinking, when you look at that y table on second graph and the TI, it only lists x's in whole numbers. So when you see problems like this, you have to use second trace. You have to use second trace, and I'll teach you all about that. Let's finish doing this. Now I've got the other one. Sheridan. Nope, I want to go with Alana. Alana, how are you today? See this x plus 4 equals 0 over here? How would I get that 4 to go hang out on the other side of the equal? Minus 4 on both sides. Gracias. Now we have x equals negative 4. So here are my two solutions. Negative 1/7 and negative 4. Okay, let me show you how to do this in TI so you can check. Can you tell me the two factors, please? No, the factors. 7x plus 1 and x plus 4. What was the original quadratic? Like that? Okay, here's one way to check. Hit graph and see if those two lines map directly over each other. Ready? 1, 2. Yes. Now, here's another way. Hit second graph and look and make sure all the rows line up. Everything the same? Okay, now I want to show you how to check the zeros. So let me clear this guy out. Graph this. Where are the zeros at? Uh-oh, here's the problem. Let me show you what the problem is, and then I'll show you how to solve the problem. Let me zoom in on this 0 right here. Do you see how it's not crossing at a hash mark? So you can't say, oh, bro, it's negative 1. Because it's somewhere in between 0 and 1. But exactly where? Welcome to, ladies and gentlemen, brothers and sisters, comrades and friends, fellow countrymen, workers of the world. Okay, hit second, trace, 0. And now it says left bound, What you're going to have to do is sit here and hit this button about 5,000 times until you, okay, there it goes. Left bound means to the left of the x-intercept. So that means below the line. So you see how it's blinking below the line? Hit enter. And now right bound, go above the line, hit enter. Now you've bounded the place where it's crossing the x-axis, and it says guess, hit enter. And it says it's x equals negative 0.1428571. Okay? Well, let's check, right? So let's remember that. Let's remember that. Let's go second mode and then do what you said. Negative 1 over 7. Is that the same thing we had? Good. So that's a way to check. All right? On the calculator. Okay, let's do one more real fast before we go home. Or whatever. 3x squared plus 15x plus 18. 3x squared plus 15x plus 18. No, I don't want to do that one because it involves initial factoring. Okay, 3x squared minus 17x plus 20. What was it? Okay, we'll go faster this time. We need two numbers that add to equal the middle term, which is negative 17. Those same two numbers need to multiply to equal the master product, which is 3 times 20. What's that? 60. All right, let me help you out, okay? Here's how you do these when they get a little bit harder. Break it down. Prime factor. 2 times 30. 2 times 15. 3 times 5. And now here's how you do this. So 2 times 30 equals 60. 2 times 2 is 4 times 15 equals 60. 2 times 2 times 3 is 4 times 3. That's 12 times 5 equals 60. These are all the different products. Now, the master product is positive, so the signs are the same. B is negative, so both are negative. So look, do this. Guys, if you follow this longer method every time, it will work every time. Negative 2 plus negative 30 is negative 32. Negative 4 plus negative 15 is negative 19. Negative 12 plus negative 5 is negative 17. Which one do we use? Negative 12 and negative 5, right? So, split the terms. You now have 3x squared. Bigger number goes up front. Minus 12x minus 5x. What the heck? Minus 5x plus 20. So now it's group them, factor them. I can pull a 3x out of both of these, and I can pull, what can I pull out here? How about a negative 5? Just a 5, negative 5. So watch this. So now I'm going to pull a 3x out, and then inside I have x, and I pulled out, what's negative 12 divided by 3? Negative 4. Just by negative 12 divided by positive 3 is negative 4. Now over here I divided out a negative 5. What's inside? Minus 4, right? 20 divided by negative 5. So remember, these two guys come together. 3x minus 5 times x minus 4. Set them equal to 0. 3x equals 5. Divide both sides by 3. I got x equals 5/3. Another way of saying 5/3 is 1 2/3, or 1.6 repeating. And then we add 4 on both sides here, and we got x equals 4. Let's assume we're right. Okay? That's how you do the homework. Homework is right here. And there's homework on Delta Math. Here it is. Here's your homework. So the Delta Math homework, I think I set due Friday or something. Check it out. But basically, that's all the homework right there. They're only the green ones. You see only the green ones? It's not as much as it looks like. So I actually have listed them. Make sure you're going to get a textbook today. During 6th period, if you want a physical textbook where you can just look at this stuff and look at examples and whatnot, please go to Miss Page in the library and get a Libro. Okay, bro? I'll also be online tonight. I understand that some of you have church this evening. So if you are at church, what time do you get out of church? 7 or 8? Okay, I'll be on the chat. I'll be on until, I'm on until like 9:30. So I'll hop on around 6. I'll be on until like 9:30. So just jump on whenever you can. Remember, it's DVR'd, so you can rewind the video and watch it from the beginning. Yes. Number 45.
Yes, it says and 45.
I'm trying to zoom in on it. Oh. There. Did you want to take a picture of it? What? Page 515. Samantha, come over here and bring your phone. Thank you all. You did it really good today. No, she's not in trouble. I just want to try to help her download this. Okay, I'm going to end the live stream here, guys. Thanks. It was a great class period, as usual. Buenos dias, everybody. Que tenga buen dia.